So 800 kilogram roller coaster car is released from rest. So at this location, I'm going to mark this as my little bit up. Let's move it a little bit up. Mark this location as my datum line. And when it passes through, when the car is over here, it means the potential energy is 0 according to this datum line. Okay, let's do this math here. So the mass equals to 800 kilograms and initial velocity is 0. So you have to find the minimum height from here, from this one to this position. This is the minimum height h of point A, so that the car travels around the inside loop without leaving the track. So it should not come back, it should go beyond this loop, so that what should be the minimum height h. Also find the velocity of car C at location. Find the velocity of car at point C, at location C. So when it reaches here, so we have to find out V sub C. We have to find out H. So let's do some math here. When it is inside the loop here, so the car is over here, it means the condition at it says the minimum height says that the normal reaction. So the normal reaction over here, it should be NB equals to 0. The weight is WB.
NB equals 0, right?
Yes, it's barely touching, like they're barely exerting force on the guides, barely, because the minimum. Otherwise, if the height is too high, then it will push the railing backwards. So you have to have that imagination. So NB for this case equals to 0, and you know this is my center of curvature, and you can apply the formula. All the forces equals to along the normal unit vector, they are equal to mass times acceleration, and we know that so WB, imagine, is positive upward or negative upward. So WB mVB square over rho. So what is my VB? You can help your professor by VB equals to W sub B times rho radius of curvature over M. So what is the radius of curvature? If you take a closer look, this is 7.5 meters. So this distance is 7.5 meters. So I'm going to write down velocity at location B is G square root. Actually, this should be a square root, okay? So it should be square root G rho. G is 9.81. And if you know this, then you can find out the kinetic energy at location B, which is 29,432.8 joules. Now let me take the equation of conservation of energy principles. So T sub A, V sub A, T sub B, V sub B. And if you take a closer look, initially it is starting from rest and it is passing through the datum line. So the left hand side is 0 plus 0. Agreed? Because there is no potential energy change passing through the datum. And the T sub B is 29,432.8 joules. And V sub B equals to mg. Now you will help your professor. It's a negative sign because Look, what is this distance? This distance you have to take a h minus 20. This is h minus 20. Agreed? mg h minus 20. Can I write down? Here I should write down negative sign because it's a negative energy. Going down, the datum line is negative mg h minus 20. What is h? If you solve this equation, you should get height equals to 23.75 meters. Do you understand the first part? And the next thing we have to find out the velocity at location. So I'm going to grab the same energy conservation principle, but now for location 1 and location C. Look, I'm going to replace this B by C. Left hand side is 0 plus 0. Okay. And the right hand side is how much? Half mv sub c square. What is the potential energy change? Negative because it is going down. Take a look on this picture and you will tell me, Professor, this is how far below. H depth is h, which is 23.75, which we already calculated. So at location C, this is negative mgh, which is 23.75. And if you solve for this, you should get 21.6 meters per second. This is your answer.